Welcome. I want quickly to review the reason why we need to use a constant that is foreign to the branch when we instantiate an existentially quantified sentence. You've already seen this example in class, but I thought it might help to see it again. So here's how it goes. Remember that we started with the following sentence. We had a tree that was going to start with the sentence, there is an x, f of x, and there is an x, not f of x. And again, if f of x were to be interpreted as x is friendly, this sentence would say someone is friendly and someone is not friendly. Now, if we just think about what that says, we wouldn't think that someone is contradicting himself if he said someone is friendly and someone is not friendly, because we might not be speaking about the same person. And this is exactly what a truth tree should show us. So let's follow this truth tree and see how it leads us to that very same conclusion. The sentence in line 1 is a conjunction. The main logical operator is the ampersand. And so we have to decompose it by using the conjunction decomposition rule. So we're going to write down there is an x, f of x, and there is an x, not f of x. And that comes from 1 by conjunction decomposition. Now that we have done that, when we look at our tree and evaluate what we've got, we see that we have two existentially quantified sentences, and we have to decompose them both. And in a way, it doesn't much matter which one you do first, but we're going to do the one on line 2 first. So on line 2, what we would do is instantiate to a constant that does not yet appear on the branch. Now, there are no constants here on the branch so far. I've got x's all over the place, but no constants, so I can pick any constant I want. And again, the convention is to pick the first letter of the alphabet and then follow the alphabet serially. So we're going to write down FA, and we're going to check this off. We're going to say that that came from 2 by existential decomposition. And now we face the task of decomposing line 3. Now when we decompose line 3, you'll see why it's so important to make sure that when we decompose an existentially quantified sentence, we always use a different constant, a constant that does not yet appear on the branch. When I check that off and go to write line 5, what I have to write down here is not f and a constant that is different from any constant that already appears here. Since I've already got a, I have to write down a different constant. And again, the convention is just to follow the alphabet. So we write down not fb. And that comes from 3 by existentially quantified or existential quantifier decomposition. So what you see here is that this is a completed open branch. And if we reflect on what it's telling us is that the sentences at the top of the tree can be true if A is friendly, say A is Alice, and B is not friendly, right? Then it really will be true that someone is friendly and someone is not friendly. So you see, this tree does show us the importance of instantiating to a different constant. Or to say slightly differently, we would not have wanted to make the mistake that the person who is being claimed as friendly is the same as the person who is being claimed as being not friendly. And none of this depends on the fact that we're happening to be using the same predicate. Even if these predicates were different, we would still use a different constant. So for instance, suppose we start a different tree here, and we have there is an x, f of x, and there is an x, rx, and that's our set member. And if we leave f of x as x is friendly, and we use rx for maybe x is Republican, this says someone is friendly and someone is Republican. When we decompose the sentence in line 1, again, we have a conjunction, so we write down there is an x, f of x, and there is an x, rx, coming from one line by conjunction, decomposition. And now when we go to instantiate lines 2 and 3, we have to use different constants. So from line 2, we might use A by existential decomposition. And now when I go to instantiate line 3, I have to use a different constant. I can't use A again because I don't want to assume that this person A who is friendly happens to be the same person A who is a Republican. They may or may not be. That person may or may not be the same person. So what we write down is RB. And that comes from 3 by existentially quantified or existential quantifier decomposition. Okay? So one way in which this sentence at the top of the tree can be true is if A is friendly and B is a Republican. That's one way in which it can happen, that there's someone who's friendly and someone who's a Republican.